Hi, everybody. It's Mrs. Cassill, and yes, I am still home. This is my last official day. The kids will be going back to daycare on Wednesday, and Mr. Cassill and I rock, paper, scissors for who had to stay home today. It's my turn. Tuesday, it'll be his turn. And then hopefully smooth sailing after that. I'm really excited for that. Welcome to one of my favorite labs of the entire year. And so today will be great. You'll have fun. You'll get started. And then I'll be here for the fun parts and the physics for the rest of the week. So here's your instructions. Everything is here in this nice little slides in Canvas. So roller coaster. So by now you've already done the do now. If you have a favorite roller coaster, post it. You can do this at your leisure. But here's the big bulk of your lab, right? So your goal is to find the force of friction on your roller coaster. You're going to use these sweet Italian roller coaster kits that are phenomenal and are very low friction, but the reality is they do have some friction and you're going to need to figure out what it is. So that's your goal. This entire lab, you're answering that question. You're collecting evidence to answer that question. So there's 8 roller coaster kits. I think I have more than that. I don't know. So obviously I'm not there. So a couple of the people have helped get your kits collected for me. So there's 8 roller coaster kits. I'd prefer you to choose a team of 3. That's mostly because every time I've done this lab with teams of 4, there isn't enough work for the 4th person to do, so they end up sitting around with nothing going on. So 3 people's ideal, and then no solo students. There's always somebody who wants to work on their own, but there's really too many things to do in this lab in terms of building, measuring, letting a marble go, watching it. You need teammates. So if you look around the room and there's somebody who's going, because they really want to work solo, adopt that person. We're a community of learners. Help each other out. This classroom also, remember that it's shared. Mr. Offer's been sharing it. For all I know, they're going to be in there working on the gas leak today. So you're watching this video from a different location already. So regardless, the space gets shared. Other classes are taught in this room. So at the end of class, dismantle your kit and return it in its box to the front of the room. So here's your lab for today. This is like your pre-design. We're going to learn how to measure some stuff. You're going to get started with the basics, okay? So working with your group, design a simple roller coaster that uses these materials. Your goal is to make a ramp down. We're not going to do any loop-de-loops or jumps or anything like that. We're literally making a ramp down and then a final track. Observe the picture of boringness right here. Although, if any of you have been on a roller coaster with an angle like this is plenty adrenaline filled right here. So this is fast and fun. So your goal is determine the kinetic energy and the gravitational potential energy at 3 places on your roller coaster, including the very top when it's at rest, the very end when the height is 0, and halfway down. And my little prompt to you there was, hey, can you measure that with math? Like, where is halfway down on your ramp? So ignore this picture. I don't know why that's there. I stole this from the internet. Okay, so when you've done these measurements, you can add a simple hill. So your second roller coaster, and it's slightly off the screen of my presentation here. Let's see if I can get it all on the screen. Well, that's definitely all on the screen, but teeny tiny. You can add a simple hill. No loops yet, nothing crazy pants, no moats filled with alligators, just a second simple hill. And then if you have time, measure the kinetic and potential energy at the bottom of the first dip, right? That's probably not the lowest point on your track, but find the kinetic energy and the potential energy here, and then find the kinetic energy and the potential energy at the top of your second hill. Okay, so that's the basics for the first part of this lab. This is going to allow you to test your measurement techniques. It's going to allow you to collect some basic data, to explore how your materials work and find their limitations, and make some choices as a team so that you're ready for the real beef of the lab, which we will start on tomorrow, okay? I also would encourage you to please play and have some fun. If you finish these measurements and you're confident in them, play around. You go for it, okay? At the end of the slides, there's always one of these. Sometimes we don't make time for this. What evidence can you collect that mechanical energy is conserved? That's a hard question to answer, actually, after this lab. So look around and pay attention. I have one hint for you, which is in the notes that I gave for the substitute, but is not in these slides, which is do not Measure the distance of your entire track and time your marble for the entire trip and use that to find velocity. Think about that. You've got an object that's accelerating. It's starting at rest and it's speeding up as the curvature of your track changes. That rate of acceleration will change, and it's reaching a flat track at the bottom, where again, now it's no longer being accelerated by gravity. It's simply moving forward by inertia. So do not measure your whole track. You've got inconsistent motion. You cannot say that this whole distance was experiencing the same velocity. Doing this distance divided by time would give you an average velocity for the whole trip. It will give you a wrong answer for kinetic energy. So instead, you need to figure out how to find the closest to instantaneous velocity you can. At the top, that's easy. Your velocity that you're starting with at rest, you should know what that is. At the bottom, if you leave a nice long flat track on the bottom, you can give yourself 50 centimeters or so to let your marble roll and measure over those 50 centimeters using a stopwatch. That's not that hard. You could use a motion sensor too if you want, but that bottom, use a flat chunk of track, make it as long as you can that works reliably, and use that and say, I'll find an average velocity for that flat part and call that your final velocity. But in the middle, that's a little bit trickier. Your marble's going to be going fast. It technically is accelerating. So we want to find the smallest snippet of space that you can. I want you to try to figure it out. I left some hints with the sub, so if you get totally stuck, your job is to wave your hand in the air and call our guest teacher over and say, I don't know what to do. But how are you going to find a small section of track and accurately measure a velocity there, as accurately as possible, I should say. All right? So that's that. Those are my hints for you for today. Hope you guys have lots of fun. I can't wait to see you on Tuesday to continue with this work and to get into the beefy parts of this lab. You'll notice if you look on here, this said slide 5, and then when I click forward, this is slide 9, because there's stuff hidden in between. That's the rest of your lab, right? Have fun, everybody. I miss you. I can't wait to see you again. Bye.